Good afternoon, if you're someplace where there's an afternoon. Thank you for joining us today for the XMILE panel discussion. This is Karim Chichakly. I'm here with Bob Eberlein, and we're pleased to host an XMILE panel discussion with some leaders in the system dynamics field. We have Andy Ford, Diana Fisher, Matt Carlson, and Ignacio joining us today to talk about XMILE and its role within the field of system dynamics and how it might change the future, or maybe how it may not change the future, depending on their points of view. We'll start by letting everyone introduce themselves briefly. And Diana?
Thank you, Karim. My name is Diana Fisher, and I have been a high school math teacher for most of my career. But since 1990, when I first saw the Stella software, I have been using Stella and System Dynamics in my classroom, and I have developed some lessons that I also used with my students. I have designed recently 3 online System Dynamics modeling courses for math and science teachers because I find this such an exciting and very useful method of analysis for students. And I am currently working on my doctorate in system science, and I received most of my system dynamics training at Worcester Polytechnic Institute. I think I'm finished.
Thank you, Diana. Thank you.
Andy, I guess you're up next.
Yeah.
Okay, well, I was temporarily on mute, so hello everyone. This is Andy Ford. I'm an emeritus professor at Washington State University. So now I mainly do my research on my grandchildren and the fishing. I discovered system dynamics in the 1970s and did my doctoral training at Dartmouth College. Dennis and Dana Meadows had just moved to Dartmouth from MIT, and the grad students were very excited. The biggest challenge was climbing over the TV cables to get to our offices because Dennis and Dana Meadows were constantly being interviewed about the famous limits to growth study. We had a grant to work on energy, and the grad students divided up the different sectors. I got the electric power sector, and so I have done a lot of work in electric power ever since. I went to work at the Los Alamos National Laboratory. Los Alamos was just starting to do energy research on solar, geothermal, and they had a social and economic impacts in the West program. That's where I got my start on modeling using system dynamics and getting paid to do so. The labs had a lot of really good targeted projects. We would go back to the Department of Energy in Washington, D.C., and people had important questions to ask, and there were a lot of modelers of various stripes at the Department of Energy and in the labs. System dynamics was a minority method, so often when we had to explain system dynamics, it was difficult. But nevertheless, we could do really good work until the DOE underwent a change in administration in which models and analysis were no longer useful. Politics and ideology governed energy policy. And at that point, I shifted into academia. I went to the University of Southern California, where some of you may remember Peter Gardner, who was our chair. Jack Homer was at the University of Southern California briefly. And I transferred to Washington State University after the USC program was shut down, and I've been at the university at Washington State in the environmental science program for 20 years or more. Many of you know Allison Beal. She is carrying on the program at WSU. So there's my bio sketch. I'll turn it over. Who's next? Matt, are you next on the
Thanks,
agenda?
Andy. Yes, Matt's next.
Okay. Thanks, Andy and Karim. I'm an ecologist based out of Ottawa, up in Canada, and I work for a company called Elsie's Group, working with Brad Stelfox and others to apply simulation models to explore the consequences of land use on ecosystems. So we take a system dynamics perspective in that our simulations explore the response of ecosystems at large temporal and spatial scales to the full range of drivers, so a full range of land uses and natural disturbances occurring in a region. As a quick example, we do a lot of work in Western Canada in a province of Alberta where there are numerous overlapping land uses, energy exploration, agriculture, forestry, settlements, and also natural processes like fire. And so we are doing modeling that considers the overlapping effects of all these drivers, which is in contrast to a lot of natural resource practice and research, which focuses on individual sectors. And so we feel that this analysis provides the perspective required for comprehensive land use planning. And the model we use, ELSIS, is developed in Stella. And since then we've also developed other tools in other languages to integrate with it to provide online viewing of simulations and also mapping of simulations. So certainly see the value of integration. And yeah, I'll pass it on to Nacho.
Oh, thank you. My name is Ignacio Martinez-Moyano. I'm a computational social scientist with the Decision and Information Sciences Division at Argonne National Lab. I've been here since 2007, and we've been developing work for many U.S. agencies, but primarily the work that we've been doing using system dynamics have been funded by the Department of Homeland Security and the Office of Naval Research. Before joining Argonne, I did my doctoral work with George Richardson and David Anderson at the University at Albany. And there we had the opportunity to I had the opportunity to work on many things, very interesting things, especially connected to group model building and the use of system dynamics for policy analysis. Here at the lab, we've been doing many types of model development, from the very conceptual to the most to those that are very much data-driven. And we've found that it is really challenging sometimes to do the work when we have several laboratories interacting and have many modelers doing pieces of the work in different geographic areas. So we're very excited about being able to have some standards to work together. And also, I have a joint appointment with the University of Chicago at the Computation Institute to conduct work there. And part of some types of problems that we've been able to address there are quite suitable to be addressed with system dynamics. Some other work we also have been conducting some hybrid modeling with our colleagues that do agent-based modeling, and we've been doing that for the last 3 or 4 years. I guess that's it for now.
Thank you, Nacho. I just want to remind everyone who's in the audience that the panel discussion is open for questions from the audience. You can type them in the questions panel that's on the side of your screen. And I'll kick off with a simple question, I hope. What benefits do you guys see, either personally or in general, behind standardizing the file format for models? And I guess we'll do it in the same order. Diana?
Well, most K-12 teachers use Stella. So the vast majority of models that they access are Stella models. Most teachers would not learn 2 software packages to do the same task. So Vensim models are essentially not available to K-12 teachers. I think with a standard way to make the models, the background, so that they could be read by the different packages. It would be great to have a set of molecule type models. I know they have some molecule type models, these little core models in VenSim. And it would be great to have some of those types of models for K-12. I was thinking that these could be made available to teachers as a way to start with lessons using models that were designed, say, by the people who use them in applications. Say one of their beginning models for a particular application might be donated to this particular library, and it could be read by anyone who had either Stella or VenSim or whatever system dynamics programs adapt this uniform base. And that would allow the sharing of a larger section of models for the use in K-12, which I think would be great. When I started my work and I was feeling sort of on shaky ground with my background in system dynamics, I started with models that other professionals had designed so that I felt that I was using correct models and building lessons around models that were correctly constructed. So this would be a great way for teachers to incorporate well-designed models into some of their work, and expanding it so that they could come from either the VenSim world or the Stella world would allow more good, well-designed, small models to be available to teachers, which I think would be a great asset.
So Karim, this is Andy. I'll pitch in next. My response to that question is mainly to hand it off to Matt and Ignacio, for whom I think there are high values. At this stage in my career, there isn't a big value of having a standard format, and it's probably because of the nature of the clients I do research for. They are often have a systems perspective, and they don't have an appetite for the spatial complexity that Matt described. They don't have an appetite to link multiple models together that Ignacio described. They basically see a failing of the existing library models that their own agency or companies use, and they want a fresh perspective. So where I would see the most value here at WSU is for our counterpart to Matt, the spatial ecologist, the landscape ecologist, who often use the R statistical package. If they would be more interested in system dynamics, if they could achieve an explicit handoff back and forth alive between the models they build and the models that we build in the system dynamics cluster. And they don't mean just pass concepts and ideas back and forth. They want to see models interconnected. And so what would be great for WSU is for someone like Matt to come give us a seminar and show how he does it. In a previous life as a staff member in Los Alamos, what I noticed most was that the Department of Energy and the labs had so many models you'd lose track of them all. And there was a natural call for management to work together, integrate your work, and achieve synergy by bringing all the labs and all the staff members and all the models together. And that meant often connecting them together, and a common standard might help achieve that. So with that segue, I'm going to expect that better insights are going to come from Matt and Ignacio. Okay,
thanks, Andy. I don't know about the better insights, but I can certainly provide my perspective. I think there are definitely benefits, both from within my organization and kind of outside of my organization. Within the LC's group, we, just because of there's just so many elements to the system that we're modeling, our Stella model has become absolutely massive and very challenging to manage and upkeep. Had this type of language standard been available while this model was first being developed, we would have been able to make it much more modular, which would have been much easier to upkeep and expand. And then also LCs, which is the Stella model, we use it to provide input into a GIS application that operates within the ArcMap platform to create maps of future landscape condition and also indicator condition, things like wildlife. So we need to do linkages there, and then we also then provide output onto a web-based tool that makes large databases of information. That's the outputs from these land use simulations available to basically non-experts to review the outcomes of scenarios. And all that, it's working, but it is somewhat piecemeal, and it's been challenging to orchestrate. So that process would have been aided with the availability of XMILE. Outside of our organization, I recently was at a conference of the International Environmental Modeling and Software Society, and was just struck by the number of excellent modeling initiatives that are occurring, but they almost all are focused on pieces of the puzzle rather than on how different elements of the system interact. And so I certainly see that anything that can facilitate integration across research or modeling initiatives is going to help achieving a systems perspective when it comes to modeling the effects of humans on the environment. I'll pass it on.
Hey, thanks. This is Ignacio Martinez. Here at the laboratory, we have several things that we've been thinking about in terms of having the ability to have a standard and how that would benefit the type of work that we do here. And for sure, many of our sponsors are very excited about the possibility of having a standard with which they could, our modeling efforts could comply with, so that the model, sharing and assessment and publication could be done in a more transparent way, so that they could know what types of things they could, see as part of what they are getting in the type of work that we do for them. But besides that, which is very important for us and for our sponsors, we are actually very excited because of the possibility of having a standard that will allow us to actually continue our tool development. That right now we've been working hard on the documentation tool and the analysis tool that we use for our work internally, and that we have been able to share with the rest of the field. But right now, given the tools that we have this far, and actually the software that we have primarily used, which is Bensim, our tools actually use Bensim-specific files that actually have been, it's been very good, but at the same time very limiting in terms of the types of things that we can do for others and the types of things that our sponsors are expecting from us. So having a standard will allow us to actually continue the development of tools like the documentation and analysis, and be able to actually use any type of model or any type of platform that will actually comply with this standard, and actually make the use of these tools and the potential that these tools have multiply orders of magnitude, we think. Additionally to these ideas of tool development, which is at the core of what we've been doing the last several years, is the idea, as Andy was saying, of the possibility of having a more transparent and easy to do model integration with the teams of people that we work with across the labs and with other agencies. When we do this system dynamics modeling development, it is going to be easier to just have one single type of file to share and to connect. Right now we have teams working with the VenSim, other teams work with Stella, other teams working with PowerSim, and then we have a team that actually his work is to integrate everything so that everything can be, you know, put in the same language or the same expressive process. And the other type of integration that we've been working a lot with, and that this is going to actually help, is the integration of system dynamics models with other types of models in hybrid modeling that we do quite a bit also here at the lab. So it's tool development, model integration, and model sharing, the types of things that we think having a standard will help a lot. Thank you.
So I've got a question here that I have to admit is a bit of a seed question, but I think it's a great one for the panel. And it is, have you expressed your support for the XMILE standard to your modeling software vendor? And if not, do you plan to? If you could just hear the comments on the panelists on that, that would be great.
Well, if I'm supposed to start again, the vendor that I tend to use is IC Systems, and since that's already there, I guess they already know trying to push this forward, so I don't really have anything to offer on this particular question.
Yeah, this is Andy. So I've had a lot of conversations with people, and I think I probably added more confusion rather than support to the idea. I really think that the key value of the method is in organizations with multiple models that need to be connected and shared, the example Ignacio described. And in my own experience with people who do spatial modeling, it would be great if if people could develop a way to get the dynamic modeling we do well interconnected with the GIS data bases and the ecological knowledge that the landscape ecologists have and their favorite models. To get those interconnected better would be a big step forward. So in that sense, I do support the advancement of the standard.
Matt here. I don't think I have much to add to this question. I guess, as Diana said, the main platform we use is Stella from IC Systems. So I guess participating in this discussion hopefully shows our support for the concept. But I have not yet discussed the XMILE standard to the vendors of other platforms such as Esri. But it is a good idea to do so.
This is Nacho here. We use mainly VenSim still here at Argonne, but in other laboratories they use others such as PowerSim and Stella. So I think that we here at Argonne, we've had conversations with people from Ventana, of course, but at a very informal level, asking, well, when that is going to be available so that we can actually share models. But I, at least personally, I have not had like a serious conversation about it yet. But I think that it is at the point right now, the development of the standard, that it would be a good idea to do it, maybe at the conference this year.
So let me, I've got a question here which I can answer, but I'd actually love to hear the panelists' views on whether or not it's an important thing. And the question is whether the XMILE standard allows for multiple views of models like Benson does. And the answer is yes, it does allow for that. But the question I'd like to put to the panelists is how much do you value multiple views in a model in modularity versus having a model that is one clean representation of the system so you can explain it to people? Just to get your thoughts on that would be great. If we could continue to go in the same order, that'd probably be easiest.
So when you're talking about multiple views, are you meaning like having the modular subroutines within the larger icons in Stella? Is that what you mean, like subroutine models within a larger structure of a model, or are you talking about storytelling and displaying a model in stages?
Yeah, there are actually two interpretations of this, both of which are supported in the XMILE standard, and one is what are called submodels or modular components that you're talking about, Diana, and the other one is just having different ways of representing the same structure so that you can see it in different forms. And either of those you're welcome to comment on.
Well, for all the work that I have done with K-12 in modeling, we tend not to use sub-models because most of our models are so simple. But from a programming perspective, I think sort of the top-down building of larger projects is always the subroutine construct makes it more modular, and as Matt indicated, the importance of being able to keep program models and programs documented and up to date. A modular perspective is pretty critical in my opinion, but in K-12 we just don't usually use models that large. So I guess I'll just leave it at that.
Okay, this is Andy. I'll pick up on the small model for educators theme from Diana. So I am proud of my book on modeling the environment in that every single model fits on one page, and many of them fit on half a page, and that you can gain insights about systems from modest models. When we work in client-directed research with large organizations with multiple talents, inevitably there is this tug to expand in different directions so everybody can be a piece of the puzzle. The puzzle gets larger and more complicated. And a modeling standard facilitates the expansion of more and more sectors or views. And if you can open up each view and see a stock and flow structure with the feedback controls of the flows that are transparent, that's cool. But what I notice more and more, and I'll pick on some of my colleagues who tend to show this in PowerSim models, is that there may be 40 different modules, each with a little box with a name on the box, and what's inside the box is inevitably hidden from view. And I don't think it's intentional. I think it's simply the act of people who know themselves the programming that goes on inside the box, but it's opaque to audiences watching. And I believe the idea is that, trust us, all our submodels work just fine, and in a limited amount of time to present, we're just going to say we have 50 submodels interconnected properly, trust us. And that is a real contrast to the small models that Diane and I present as teachers. So there's a certain tension when teachers witness such presentations, but that's partly because we don't operate in the medium of large-scale consulting, for example, that happens with the labs at the U.S. Department of Energy.
Okay, I'll take over then. I mean, I guess yes. I think being able to have multiple views of the model is very important. Often in the work that I do, any specific module or component, you need to go into a fairly high level of detail, sometimes just to gain support from stakeholders or experts of individual fields. That said, I strongly believe that it's the relationships between the components that are most important when it comes to simulating the behavior of the broader system. And so I think it's important to be able to view the details of an individual component or module, but much more important to be able to view the relationships between modules, and I think that's an area where there just is not enough attention right now. And I think this type of an initiative will make it easier for people to focus on the relationships between disciplines and models.
Okay, this is Ignacio again. In the type of work that we do, definitely having the possibility of using multiple views and submodels is crucial. It is something that without that we wouldn't be able to actually do what we do. And it has many dimensions to it, I guess. The multiple views capability is crucial to be able to show to the people that we interact with, which in many cases are policymakers and in some cases are subject matter experts, the different pieces of the model that are relevant to what they do and relevant to what the type of thing that we're trying to show to them. And of course, we are trying to make these views following the best practice, if you will, or what Andy was mentioning, a single page models in themselves so that we can contain a nice system story in each one of those views. But at the same time, there is this tension of having in the background all of these multiple views interconnected and have the possibility of having enough confidence in that all of those interconnections make sense. We've been working hard, and we're trying to do some more work on having these types of views and submodels and multiple interconnections be presented in ways that are useful for the sponsors and actually be able to be analyzed in such ways that can generate enough confidence. It can generate confidence in that the type of work that we do is robust and it is useful. Therefore, going back to the question that Bob posed, definitely having multiple views and the possibility of having submodels is crucial for us, and we would like to have even more of that and the ability to then go back to the simplified versions of the model so that we can communicate them properly.
Thank you, everyone. We have a general question about someone wanting to get system dynamics going. NOAA does not use system dynamics modeling software like Vensim or Stellan, I think. NOAA uses many models to predict populations of fish and crabs in the Bering Sea. How would you suggest approaching NOAA to use XMILE and system dynamics?
Well, I think my experience has always been try to find people who are a little bit dissatisfied with the way things are being done currently and talk to them about the method that you have found very accessible and powerful for this kind of analysis. Sort of trying to find people who are open to a new method rather than, it's so similar to trying to teach teachers a new method. If you do a presentation to a group of people who have been more or less forced to listen on a professional development, you have a lot of resistance. But if you can find people who are somewhat interested and get those together, I think you have a real chance to make inroads in showing them using their problem a way that is very accessible. The beauty to me of this approach, as opposed to traditional math equations, which are not a friendly user interface for most people, is that it is so visual. And I think a lot of professional people feel so much more comfortable when they can see a display of the problem with a structure that makes a lot of conceptual sense to them. So it's finding people who have an open enough mind to listen to what you might have to say, using their problem so they recognize the components, the beautiful ability of the modeler and the client to be able to speak to each other as the model is being designed are all really powerful. So somebody has to find at least an inside person who can find some of their friends willing to get into a group to have this first meeting. I don't think you can talk to a broad audience and convince most people. I think you really need to find somebody who's willing to think about a problem differently, open to it, to be productive in the amount of time that it's going to take to get something started. That's just sort of the similar situation from the teaching perspective that I'm familiar with. So that's my input.
So this is Andy. I will mention that it's people and previous applications that make the case for doing an application that NOAA might support for coastal zone management. One of Diane's classmates at WPI was a NOAA staff member, and she worked with others to try to get more of a systems perspective on climate modeling. And everybody who's exposed to climate modeling in general knows that the whole field is dominated by separate, uncoupled models. And when you actually do analysis that couples different climate models together, the key feedback loops, which happen to be vicious circle loops, suddenly change the severity of the climate change threat noticeably. So people in climate ecology and climate change in general are all supportive of model integration, model coupling. As for NOAA and fisheries, you go to the people who have already done good studies and point to their success. You might refer to get people introduced to the problems of overfishing as you might refer to the fish banks game and have people come together to play the game. You might look at the work of Erling Moxnes in Norway on the fishermen there who have managed to avoid the tragedy of the commons but have ended up over-investing in their boats. You might go to the University of Lisbon in Portugal, where they have an ecological economics group within which they do good system dynamics, and there's a major stress on fisheries and coastal management. So it may not, the answer I'm giving you may not be a software-based answer and a Common Core answer. It's people and their previous successes that will make the case to NOAA to support future work on the fishery that was mentioned by the questioner.
Okay, this is Matt. I agree with Diana that a case study type approach, coming up with a good example, is very useful for gaining support of a systems perspective. I think when selecting a case study, it is useful to try to select one that is inclusive as possible in terms of the stressors that are affecting the system and also the range of indicators that you're looking at, because that's going to support or demonstrate the value of a systems perspective. So looking at fisheries management issues over large spatial scales and also temporal scales is going to be the type of situation where I think a systems perspective is going to show the most value. And I guess the only other thing I'd add is if at all possible, when trying to achieve integration between more detailed models, is try to keep the individual component models as simple as possible at the start. not getting bogged down in the intricacies, but rather focusing on the relationships between the components.
This is Nacho. I have not had the opportunity to work directly with NOAA, but in our experience with agencies that we've interacted with, one of the approaches that we've used is not actually tell them about anything in particular, just go and ask about the problems that they are experiencing and provide possible solutions to it. So in terms of adopting the standard, I would go more along the lines of, well, try to figure out what are the problems in terms of their use of models and how they have accomplished interaction between models or model integration or model sharing, and say, well, you know what, by the way, these type of things would be easier to be handled with if there was a standard and you were to adopt that standard. So it's more like going from the problem to the specific solution of having a standard to dealing with it than the other way around.
Great. So I have a couple of related questions I'd like to read out for the panel. In K-12 education and in general, it has been demonstrated that the real value in system dynamics learning is a consequence not so much from interacting with existing models, but from participatory construction or reconstructing basic models. Does the XMILE standard facilitate the building and understanding of basic dynamic models by relative novices? If so, how? And the related question is, if implemented, is XMILE going to improve facilitation of collaborative process in developing models? And is that the view? So if you could comment on those, that would be great. Diana?
Yes. Well, the development of model building capabilities in students is the perspective that I have always used in my instruction, and I have found it very empowering for students. So not all K-12 teachers feel this way, but I feel strongly that if it's possible to teach students to build models, that is the approach that I think is particularly beneficial. There are a lot of issues with why teachers might not want to do this that I don't think we need to get into here. But a standard that allows us as K-12 educators to have a broader base of small models to work from and develop lessons around is huge. The ones we've developed over the past 20 years, those from the Creative Learning Exchange and from the Waters Foundation and from other organizations have been really helpful to take this forward. But if we had access to the use of small models that have been built in VenSim, that would really expand what we can do in K-12. So having a common underlying thread, underlying language that would allow communication. Another issue also is being able to put some of these models on the web, which for Foreo, I guess, is a huge issue, having different language bases for the software. That's going to be pretty critical in K-12. And so another thing I would like to talk about is that not much has been done by other professionals building models for K-12, but if there were a common language, I think there would be they would see some real value in developing something for an audience that is actually going to be able to use this over a longer period of time. So I think model building is essential. I think it should start probably at least in the middle school, and having a common language is going to be critical in allowing us to increase the number of models available to the students that we teach. I don't know if I've answered all of the all of the parts of the question that you asked, the multiple parts. Is there something else you wanted me to address in the question that you asked? Bob?
That was great, Diana. Thank you.
Okay.
So Bob, I'll start next in the sequence. So I teach system dynamics to sophomores and juniors at the college level. And I believe that the standard would be helpful for teachers and other educators because in a one-semester course, I find they can't learn enough to have a class project that starts from scratch. And so we give them existing models of one sort or another. It could be a model of a fishery, for example. And the students are then supposed to expand the model in some new direction of interest to them. And a set of submodels would be very helpful for them. It kind of reminds me of the Lego sets. So my grandchildren are really creative when they start playing with Legos. And in fact, the older boy just came back from Lego camp, where he's learning more and more how to be creative with Legos. So if you think of these submodels as the various standard building blocks of a Lego game, our students can be creative and thoughtful at the same time. What I would recommend that the instructors do is call on the learners, the students, to test every new block, every new piece they get, with a test to prove it performs as expected in the context they will face. And the reason I recommend that test for all instructors is that students grab a submodel of some sort, stick it in, and assume it will work for them. And that limits their learning and exposes them to errors down the pike that can't be properly discovered. So trust but verify. You know, trust that it was built by people who knew what they were doing, and then verify it's going to work for you. And yes, this will help in education at the college level as well.
Okay, I'll just say a couple things briefly. I think that I don't know if this is directly what was wanted from when this question was asked, but I don't spend much time in the educational arena. But I think that one of the benefits of an initiative like XMILE isn't necessarily well, there definitely will be benefits of sort of the technical integration of models, but I think just the interaction that it is going to stimulate across disciplines will be the largest benefit. There's just so much to learn from interacting with people in different disciplines. So I think that will be very progressive. I guess just what I'm thinking of here is that the technical limitation of integrating models isn't the only barrier we need to be concerned about. I think there's also many institutional type barriers that are limiting integration, those sort of reductionist research approaches into more systems perspectives. Things such as availability of funding or opportunities to publish, and just general willingness to give up control of your research in favor of achieving benefits of collaboration. So I think XMILE is great. It should support collaboration across disciplines, which is excellent, but there's other things we need to be worried about as well to make that happen.
This is Nacho. With respect to this question, I don't think that I do a lot of let's say education on how to do modeling with sponsors of our work. However, I do see this standard as enabling or enabler to actually share the results of those sessions that we conduct with subject matter experts. We don't do directly like any type of modeling like formulation with them. So we do a lot of sessions with the subject matter experts to elicit knowledge and elicit structure from them. So what we use is basically stocks of flows and diagrams and stuff like that. So we don't go to the point in which we actually formulate things in front of groups or with them. So for that type of application, the development of a standard is not going to have much of an impact in the actual interactions with them, but for sure it's going to impact a lot on how to share the results of those sessions.
Great, thanks so much. So we have time for one last fairly short question. This is a kind of a general one, but do you have any comments in the direction of use of XMILE as an integration of knowledge disciplines? And if the panel could comment not only on whether or not we can bring together different knowledge from different disciplines in a place, but also if we can bring together the viewpoints and help people understand how they fit into the system using these kinds of models, that would be really nice. Diana?
Well, I think already we are able to cross disciplines with the structure that we have. What I would like to see is being able to bring in some ideas, say, from agent-based modeling, or to have potential slightly different interfaces that speak to different audiences a little bit more. So the structure right now of the stock flow design, I think, crosses disciplines very, very nicely. If there are different ways to show results that would perhaps improve cross-discipline, certain things can be done more effectively using sort of the interface of an agent-based type situation, although that's really a different way of thinking about the problem. So I don't know how easy that would be to integrate, and I have not in my work come up with problems where I would need to have system dynamics and agent-based in the same particular modeling effort. So I can't really offer much. I think that the system dynamics interface is already very cross-disciplined for what I would like to do, although the interface could be improved a little bit. So that's all I can really offer.
This is Andy. I'll offer a view of interdisciplinary education and research where the emphasis is on interdisciplinary, not multidisciplinary. I'll bet the panelists are unanimous and the people listening in are unanimous in seeing the value of doing interdisciplinary work and integrating the learning from different modeling methods used on the same topic. The key when we go to integrate is whether we do it with the software or we do it conceptually. And let me give you an example. Well, let's take agent-based models that Diane just mentioned. In the world of ecology, an ecologist named Grimm has recommended that agent-based, or they call it individual-based models, be used to provide supporting information for the more aggregate models that would look familiar to people in system dynamics. Models of an entire population of predators like cougars, an entire population of deer, perhaps with stocks for young, old, elderly, male, female, but perhaps only 5 or 6 stocks, not a model with each individual animal going through the trials of predation and escape and so forth. Now, when the agent-based modelers come up with good, insightful work, the choice is, do we use software tools to mathematically computerize an integration, or do we talk with them and ask them what they can teach us? And if they can provide a performance curve of cougar kills per week as a function of prey density, that would be number of deer per 1,000 acres, if they can provide that curve, that is invaluable for predator-prey models. And so what you are doing is asking them to summarize their results with some sort of performance curve, and if they can do that, that is a huge step because it turns out that that particular relationship is key to predator-prey models. In an area that Matt works on, hydrologic modeling, a story happened to me when I was doing work on the Snake River Plain in Idaho, and we had a colleague with a super good, dynamically complex, three-dimensional model of hydrologic flows. It was the flows of water in and out of the Great Snake River Plain aquifer. And these are models that use numerical methods to simulate complex partial differential equations. And our colleague had the best model going, and the question was, get a grant to integrate that with a system dynamics model of what's going on the surface, the dams, the agriculture, and so forth. To his credit, this colleague said, no, don't stick my model inside yours. I've got performance curves. And what they do is they teach you, if you start pumping water out of the aquifer at point X, the spring flow at point Y will show the following performance. It will drop over time. And it turns out that that performance curve looks just like a first-order exponential approach to a target. And we have the easy way to represent that in Stella or EventSim or PowerSim or a new standard with just a first-order smooth function. And now you can represent the spring flow for aggregate levels using a first-order delay of the water flowing into the aquifer and exactly match the best three-dimensional model of the Snake River Plain aquifer. And the key was the willingness of the people working at a more detailed level in space or in time to create performance curves. And if they don't have summaries of their results, you might ask yourself, what good are they? Because everybody has to summarize their results to someone or another, and if they haven't summarized, I'd be suspicious of trying to integrate with them using software and computer science technologies.
Okay, this is Matt here. I'll give an example also with hydrologic model, perhaps somewhat similar in that I think it demonstrates that one of the benefits of trying to integrate models across researches or across disciplines is it really forces you to really listen to what the other person's research is saying. And for example, the type of work that I typically do is looking at changes in landscape composition over long time frames due to various natural and anthropogenic disturbances. So kind of looking at annual time steps, decades into the future. How is the area of different natural cover types going to change, and what does that mean for things like wildlife or runoff of water? Hydrologic modeling is typically cares much more about small time steps. They're looking at hourly or daily changes in flow, short-term changes in water demand, and implications of small-scale physical attributes, things that affect a flow within a river itself. And so, by talking to each other, we've had to become comfortable with shifting the timescales that we're working at. So we are now operating at monthly time steps instead of annual time steps, and the hydrologic modelers have become comfortable with that as well, and they are gaining new insights from our focus on changes in landscape composition and what that means to flow within rivers, and we are gaining insights from their smaller time steps and their focus on water use. So that's just an example, I think, of how actually having to integrate models really makes you collaborate tightly. Another, I think, just opportunity for integration across models, something that XMILE could facilitate is participatory modeling with stakeholders. The type of work I do, the modeling is really the intended benefit is try to change or inform the way that people think about land use, about the consequences of their actions on the environment. And the ability of models to do that is just so much greater if people are involved in the modeling process itself, both because they'll trust the models and because just interacting with the model, that's how you gain the insight. So I could see a point in the not-too-distant future where we could be sitting in a workshop where stakeholders are actually changing stock and flow models for one component and then observing what the consequences are to a more detailed system model. And I think that's really exciting.
This is Nacho, and I'm just going to make this quick because I think we're out of time by now. But I think that the benefit of having a standard in terms of promoting collaboration with other disciplines and with people that think slightly differently than what we normally do in the system dynamics world is by providing a platform at which they can stare at and say, oh, so now I understand what are the ways in which you put these things together, and I can take that back with me to my area of expertise or to my type of modeling and work with it in a stable manner, and that it's not going to change depending on what type of software you're using. So in that way, that might have a good impact on these collaborative ventures. Thank you.
So we're out of time. I would like to thank the panel very much for their contributions. Andy, Diana, Matt, Nacho, you've done a great job. We will be having a round table at the System Dynamics Conference in Delft for those of you who will be attending, and we'd love to see you there and meet many of you in person that we've only been able to talk to over the webinar series. We will continue this webinar series in the fall, probably going to look at more use cases, more case studies of people who are doing interesting things in the field. And we hope you'll be able to join us again then. And for everyone else, have a great summer, at least for those of you in the Northern Hemisphere. Thank you.